All right, well, welcome to class. We're going to talk a little bit about installation and localization. We're talking about what do we need to do when we first prepare for an OS install.
Make sure you got enough space on the hard drive.
You got to do your hardware compatibility list, right? Term that Windows uses, but basically you got to make sure you have the software. You have the requirements to install that software, whether it be your RAM, your hard drive space, your CPU requirements. Make sure that your HCL, your hardware compatibility list, that all your devices can support that operating system. Okay. Any of your peripheral devices, such as your video cards, sound cards, things of that nature, right? Well, we also need to identify not just hardware, but software. Because what happens when you go up from a 32-bit version to a 64-bit version? 64s can run 32s sometimes if you have the right emulator or right emulation capability on that operating system. You also need to identify what you're going to call your computer, right? Your host name. What kind of network infrastructure do you have? Do you have a DHCP infrastructure? Do you have a static IP infrastructure where you have to give it a specific qualifications? Are there specific software packages, security-based packages that you're going to have to install in order to be successful, right? In order to do this, there's a lot of distributions will give you a pre-installation checklist. Things that you need to check off and make sure that you have installed or you meet certain requirements. It just kind of, how many of y'all have heard of a pilot's knee board, right? Pilots have knee boards for checklists for takeoff and for landings. It's just a little pad they keep on their lap that gear down, my flaps are down, I've reduced my speed to 120 knots, whatever it may be specific to that. Are my ailerons set? Am my brakes good? Do I have all my indicator lights? Am I on the ILS approach frequencies? Going step by step in that analogy. Same thing with the pre-installation checklist. It's what you would do to make sure that your system is ready to function for install. It's going to cover your CPU, RAM, keyboard, mouse, all this type of stuff. And here's just some samples that you might want to think about. How much RAM would you want as a minimum for an operating system nowadays? Probably 4, right? Just so you can have a good, solid system. I don't know of many machines that you're going to be able to put a OS on that goes on a gig or less, unless you're really going back in distributions or configurations. What type of packages? Again, are you going to put Apache on there so you can have a web server? You're going to do Emacs. What type of desktop are you going to do? KDE? Are you going to do GNOME? You can have a Samba server so you can correlate with Windows machines. Make sure that there's a Linux driver for your video card and for your sound card, right? Those are kind of things that we need to think about. There are different ways that you can actually install on Linux compared to Windows. What are the 2 ways for Windows? There's only 2 ways to install Windows. Network installation, which could be, or buy a DVD. Those are your 2 ways. Now they have unintended installs that you can do either way from either. You can do attended or unintended on each type of set. So essentially, if you want to consider it 4 types of installs, so be it. But generically, you have your PXE boot or PXE type environment where you can do it over the network, or you can do it with DVD. Unlike Linux, where you can do it from a web server, you can do it from an FTP server, you can do it from file servers, you can do it from a Samba server, you can do it as a package download, you can do it from CD-ROMs, you can do it from DVDs. There's a whole gamut of different types of installation methods for Linux. With the first thing you're going to do once you put the CD or DVD in, it's going to give you a welcome screen, and it's going to say, would you like to check for errors? always check for errors. Why? In case you skip something on your pre-install checklist, it'll let you know, hey, this video driver, we need to update this, or you need a different video driver for it, okay? It can do all sorts of things for you to give you basic install configurations, setups. But basically, it's there to help you as a secondary way for a pre-install checklist. So here's what you're going to have. When you first come into Fedora, you're going to have install new system or upgrade it. You can install system with a basic video driver, which I wouldn't do. You can rescue an installed system. Those are your backups. You can boot from the local drive, or you can do memory test. Okay? So in this instance, we're just going to do an install of a new system. It's going to ask you to perform a test on the media, just to make sure the media is good. You want to make sure that the data that's on that DVD drive is available for you to use, right? You don't want to have a bad disk in the middle of it and find out that you've crashed and you've overwritten your Windows and you can't go back and create you a new disk, right? That would kind of suck.
Is there a way to do that, like Windows, to test compatibility and see if it will take the install prior to?
Oh, from a Windows. Let's say you have a Windows
7,
machine.
Yeah, Windows 7 or whatever will let you. Windows 7 and 8 will let you do that. It'll test your machine first before.
Right. Yeah.
Is that similar?
Well, when it's talking about the media, it's talking about how you're installing it. Is it corrupted or not? I'm sure there are software packages that you could do it with. Let's say you had a Fedora 17 and you want to go to Fedora 18. I'm sure there's a package download that will do those hardware compatibility checks. But usually if you're just going up one version, it's not that big of a deal in Linux. Now, if you're going up 5 versions, I would definitely make sure you check it. Because 5 versions could be 5 years. And 2 years in computer life is a century. Choosing the language of the keyboard, obviously you want to make sure, since we're here in the United States, you use an English keyboard. The 108 or is it 108 characters, 110 characters? I forget how many characters on the keyboard. But anyway, y'all know what I'm talking about, these standard keyboards here. You want to select what type of internal device you're going to use to host the operating system. Is it going to be a SCSI? Is there a pre-installed installation folder already ready to go? If not, you're going to configure those basic drives. Remember SDA, SDB, which is your standard disk A, standard disk B. Are you going to put them on a SAN or specialized storage device? Okay. And right here, here's where you choose the keyboard layout. Obviously, we're going to ask it to do the, I'm sorry, not the keyboard layout, the language in which you're going to read all the instructions for your install. You don't want to put it in Mandarin if you can't understand Mandarin, right? So you're going to do it in English. The keyboard layout, US English. It's always fun if you do a different keyboard layout and try to install it. You keep hitting enter and you're hitting 1. You know, depending on what country you're in. The countries are different keyboards. It's kind of funny. I actually had one time where I had a German keyboard. And it had all the German characters on there, and functionalities were completely different. And so I chose the German keyboard for the install. It worked great. But after that, I switched back to an English keyboard. And it's because I wasn't paying attention to my pre-install checklist, made sure I had the right keyboard in there that I'm used to. But it was really interesting because it was my cousin's, who was at the time was a foreign exchange student. And he had brought his computer over. And he had that laptop. But by default, on a Linux system, you're going to use the localhost.local domain naming scheme. You're going to make sure that you're in your correct time zone. Obviously, you don't want to say you're in Europe unless you're trying to placate Facebook and flash video games that are on Facebook or something like that, and you're trying to change your time zone so that you can play a little bit longer. Actually, you go the other way, wouldn't you? You're out to Hawaii, so you can give you a few more hours. Important authentication. You want to make sure you have a valid username and password. Why is that important? If you don't have a valid login, you kind of screwed yourself there. When you install Linux, it's important to configure two different accounts: an administrator, root account, and a user. Why? And you should do this on Windows machines too.
Because
But
you don't want to have your primary user to have admin rights to mess
exactly, you want to keep that separation of duties. Y'all have all heard of that term many times throughout the security classes. That's your separation of duties. Make sure your administrator login is completely different than your user, so that you don't confuse them and you know which ones you need.
Plus, if you leave it.
Yeah, if you leave it unlocked, then you really screwed yourself there. All right. So here's the screen you're going to see asking for your host name. On Windows machine, all you have to do is just give it a computer name, which is the same thing as localhost, and then you add on to a domain later in the Windows environment. But in Linux, you have to put it on there first. By default, it's there. I usually just hit next and go on because I don't want to sit there and have to fiddle with coming up with my own domain at this time, unless I'm making, unless it's a server already, then I would have my domain, obviously. Okay. Time zone. I like the Linux version of time zone where they give the map and you can just click on one of them and it'll take you to that time zone, so you don't have to scroll down in this thing. But you can do that too. It's either or.
The host name, is it the machine?
That's the machine name. No, that's machine name. And then give it the root password. Now this is where, when y'all were installing, you set your password, and none of us paid much attention to it because it was just typical for you to created this account. You put in a password, and we neglected it. And we couldn't figure out why the administrator password wasn't Tor. Now this is where it is. And thanks, Mark, for reminding me because I completely spaced it myself. Because I thought I'd already set that for y'all, but it kept redoing itself, and that's why. The most common storage devices, you're going to have a PATA, SATA, or SCSI. Parallel Advanced Technology Attachment, serial. Most of the time nowadays, you're going to have a serial on a Linux box because it's usually serial type. Your parallel was your old IDE type cables, and then your small computer systems interface or your SCSI devices came in just shortly after your IDEs, but now SATA is really the most powerful connectivity throughput. Each hard disk is going to be divided into partitions, very similar to Windows. Both of them can have a maximum of 4 partitions, primary partitions. Now you can extend it, have an extended partition with multiple more logical drives after that if you want, but you're going to have 4 basic partitions and that's it. Same thing in Windows. Okay. Here's your masters, your HAD, your HDB, your HDC, your HDD. Those are your hard disk drive. Your hard disk A, hard disk B, hard disk C, and hard disk D, in that order. Your 2 primaries followed by your 2 secondaries. So when you're in your ETC, you're in your mount folder, and you see MNT/HAD, that's hard drive A. I'm sorry, it should be HDA, not HAD.
Yeah.
Sorry. I meant to get that changed. It's just an image. The book that I got this from is the one that we had for class last semester, and it's wrong in the book too. I was like, why does that look weird? But it's HDA. Hard drive A, hard drive B, hard drive C, hard drive D. Now, you can actually have more when you have your primary partitions on hard drive A. You can have hard drive A1, 2, 3, and 4. Then we have our extended, starts on your 4th partition. Okay? You have your 3 basics. Your 4th basic one would become your extended, where you have the more logical drives. I'm adding 3 more logical drives, so that's why I can get up to HDA 7. And those would be like CD, E, F, G, H, and I, right? Did I give you all that understanding, the difference there? Michael, you look confused?
I'm all right.
You all right? All right. Anthony, you okay? All right. File systems in themselves can be attached or mounted to any directory. Just like you're mounting a hard drive to a directory, a file system can be mounted as well. You can have a minimum of 2 different partitions. You have to have one for the virtual and one for the root. Okay. Like we said, we went over these. Here's the boot, the home, the user local, optional, variable, and temporary. Okay.
Can you go back? Are
Sure.
Are we talking about partitions, or are we just talking about the directories?
These are the
On
directory.
partitions?
These are the file system subdirectories.
And the only, because in the book it was talking about the only, they were recommending at least, well, they broke the hard drive down in 4 partition, and also had logical ones because they said you should
Right there.
You should have this, this, and this on this, or not you should, but it's recommended. But you can, like I said, you can just have the swap partition.
Right, the EXTs and the yeah, we're gonna get to that here in just a
Okay,
second.
and the only reason why they break it up is because in case the system crashes.
Exactly,
install-
not everything's on one. And here you go right here. EXT2, your external 2 is used for most Linux computers. 3 and 4 basically just for journaling. VFAT partitions, you can put a Windows on it. So if you have a Linux system and you have a FAT partition, that is where your Windows machine is located. All right. I never use Riser, but you can use Riser as well. Journaling, all it does is basically is your pointers or to your different files. It's just a record keeping area. I usually only have ext1 and ext2. And occasionally I'll have ext3 just because for journaling purposes it requires it. But other than that, I don't really touch anything else. And I don't like to dual boot Windows and Linux machines. That's my personal preference, but do it as you will. Okay, which type of installation do you want to do? In this case, we're going to replace an existing because you don't have it, or if you did have it, you want to replace it. And then it's going to reformat and redo all your partitions. This is where you get your choice to do so. When creating a partition, you want to say what type of partition. Is it going to be an EX2, EXT, or EXT3, EXT4? Is it going to be a logical volume manager where you have more volumes and partitions on there? Is it going to be part of a RAID environment? This is where you're going to specify all this type of stuff is when you're configuring the drive specifications. Then you're going to have a bootloader. How many know what the bootloader is for Linux? Grub. Grub is the GRAND Unifier bootloader. And it's configured on Fedora during install. Okay. If you want to dual boot it, you can choose that which OS you want at startup. That's pretty common, just like on Windows. If you put 2 Windows installs on there, you'll get the choice. But if you're going to do a Linux Windows boot, add Linux second, because Grub will overwrite the master boot record and put itself as the bootloader instead of a Windows bootloader. All right, makes it a lot easier to get into Linux system. Grub can handle both. Windows likes its own self.
So what happened to ISO Linux?
To an ISO Linux? What do you mean?
It's an old bootloader.
Grub is just the new fad. I haven't dealt with ISO because I came in really when Grub started becoming popular.
Right.
But you can use it if you want to, I guess. But you would want to use a Linux bootloader over a Windows bootloader if you're going to dual boot. And then here's just the bootloader. It doesn't look like very much, but if you don't have this box checked and install the bootloader, then guess what? It's going to use Windows bootloader. And if you really want to have fun, you can use a bootloader password. So they can't boot in if they don't have the password. All right. Bootloaders, like I said, reside on your master boot record. They are in the root partition, or the boot partition, root or boot. And all it does is allows in the successful boot of the operating system. Okay. It's part of the selecting of the system, what type of system are we going to do? We're going to do a graphical desktop, a software development, a web server, minimal. You have that choice. What specific set? And you can also pre-install the software packages that you want right here. You can say, I want all these type of repositories. All right. Pretty simple. Any questions? You, Chris?
I have an unrelated question.
Sure.
When you're installing and you get to pick the partitions,
Mm-hmm.
is it necessary to actually partition them, or can, for example, dev and swap the folders on the root partition?
No, they're going. You'd really want to keep them separate, honestly. That's why I accept the defaults on a lot of the Linux install, because it keeps it separate for me. But you could logically create them, but it's not going to point directly to them, because it's going to create it anyway inside the install.
I installed Ubuntu earlier, and I only got 2 partitions, root and swap. So that's why I was curious.
Yeah, you can create any folder you want, but depending on how you set what repository you set up, I mean, you may have put minimal.
I just said default.
Yeah, and I don't know which version, and what specific one you did or how you clicked through it, but if you accidentally clicked minimal install, that's probably why you only got those 2 partitions.
Okay.
The more repositories you check here, the more partitions you're going to get. Well, not necessarily partitions, but more folders that can reside on multiple different partitions.
Okay.
Also, you come in here and now you can select, after you've selected your repositories, you can select your packages. This is where it comes in very handy if you're going to have multiple languages so people can come on there. I don't install a lot of languages. I keep it in English because no one else is going to get on my Linux system. Servers, that's where your Apache and things of those type of your FTP servers are going to be. Development, if you're doing any coding, applications, could be games, things of that nature. Desktop environments, always at least have GNOME and KDE. That way you can go either way if you need to. I've never really dealt with XFCE, so I'm not sure which one that is. But I know GNOME and KDE pretty well.
Do you prefer GNOME or KDE?
I deal with both, so it doesn't. Just depending on what I was doing, if there are some applications that I know that I've dealt with that actually work better with one than the other, and it shouldn't really matter. But it's just your preference of how you want your screen laid out. Really, it does the exact same functionality. It's just the look and feel of it, and you can always change it at login, so that's not that big of a deal. To complete the installation, you're going to click on your license agreement, user accounts, or set up any extra user accounts. You're going to see if your date and time, you're going to match it to your NTP or your network time protocol. And they have the different locations. NTP is also set up to the atomic clock. And then the confirmation of the hardware that you're going to use, whether it be SDA or HDA, HDB, things of that nature. And then log in with your user account for daily tasks, and then you can have a network login too if you're part of a domain, just like Windows. Here's what's going to happen. Y'all remember after you took that initial snapshot, you came in, this is what you saw when you booted up the second time. Create a user, and you can say it's going to be a local account, LDAP, which means it's on the Lightweight Directory Access Protocol. Same thing as Active Directory. This is your network infrastructure. So is network login. Windows bind, you're binding it to the Windows. So if you're dealing with a Windows Active Directory, you can do WinBind or you can do LDAP, either or. And I've never heard of free IPA, so I don't know what that one is. Advanced options, enable fingerprint reader support. I guess this machine actually had fingerprint reader where they would install it on. Enable local access control. I like to leave that checked if you need that for security purposes. Your password hashing algorithm, at a minimum, have SHA-512. At a minimum. Okay. I like to create home directories on that first user login so that the first time this user logs in, it'll create those directories for them. Instead of just doing it now, I'd rather it just create it when they first log in. So the user can see, because it'll pop up the box, here's your home folder. It kind of gives the user some idea of what they're getting themselves into. Date and time, you can synchronize it over the network and it'll go to your NTP server. Or you can set it specifically if you wanted to. Hardware profile, you can send the profile. Don't have to send the profile to the Fedora project. All it does is say, here's the type of hardware that I'm running it on. If I have any errors, you can send these reports to them, and it helps them diagnose for compatibility issues. Let's talk a little bit about the dev directory. What is the dev directory? It's your device directory, device file. All it does is represent a system device. What are those devices? Anyone know? CD-ROM, DVDs, hard drives. Any type of physical infrastructure you can plug in inside your computer or into your computer will be a device. Simple. You have two different types of devices, though. You have a character and a block. Okay? Character devices transfer data between the computer and that device one character at a time. Versus a block, which transfers in chunks or blocks of data to that device. All right, which is going to be more efficient? Block. So here's some of the block type you're going to get for common devices. Your hard drives, your SATA drives, your loopback drives. What's the purpose of a loopback drive or device? So you can talk to yourself. I need a mental checklist here. First floppy disk is going to be FD. If you find a floppy disk on a Linux system, it's pretty old. I don't see any floppy disk much anymore. Your character ones are going to be your terminals. Anything that are going to be single point, like they're going to be parallel type stuff. You're going to be your mice, your null device, SCSI tape drives, things that need to matter for the bit-to-bit type connectivity, on-off type connectivity. All right, COM ports. Y'all know what a terminal is, right?
Yep.
All right. Here's a question you'll see quite a bit. Underneath the dev directory or the device directory, you're going to have a major number and a minor number and a device file type, okay? The major number points to the device driver in the Linux kernel. The minor number points to that particular device. In the device file type, major number and minor number make up that specific character device or characteristics of that device.
How do we, oh, never mind, make dev. Sorry, I thought we were still in dev for.
Yeah, you can recreate a device file by the make dev command. Or you can do it with the make nod. But you have to know the file type and the major and minor numbers.
Yeah, I guess I'm not saying the major minor. I'm in the dev directory now. I'm looking through it.
It's the device driver. It's the driver itself.
How do I see that? I did ls-a.
That's just going to list them. You have to actually go in to that folder.
Okay.
And on that device, you should be able to go to the properties on it.
Okay.
And it should give you the device, and it'll say driver 12.2.
Okay. So do we need to know how to do that, or just
No.
memorize that up there?
Just know that what the major and minors do, what they're for.
Okay.
Okay. And that is not as important as some other things. It's just a helpful tidbit of information. File system. How organized do you want to be in a file system?
As much as possible.
Yeah, you don't want to get chaotic like my NAS drive, where I have the same directory copied like 6 layers deep of the same information. I don't know how it got it that way, and I just never spent the time to go and undo it. Formatting, all it does is create a file system on a specific drive, or if you reformat it, basically you're just clearing it off to make the space for a specific device. That's all you're doing. Here are your file system types: your BFS, your CRMFS, your extensions, or the EXTs, 2, 3, and 4, HFS, HPFS. All right. This just gives you a little bit more in depth as to what each one of these are. Your boot file system, basically, is just a file system that holds the necessary files for booting. That's where grub is located. CRMFS is your compressed ROM file system, and it's basically just a storage space for Linux, for embedded Linux systems. You see a lot of that on your phones, on your Android phones. So if you go in and you find your CRMFS folder on your phone, now you know where it's at. ext2, that's just your traditional file system. All it does is it gives you your user permissions and basically just gives you the extended file system partition information. And 3 and 4, like we said, we're just journaling and so forth and so on. Then you have other, like we talked about, VFAT, virtual FAT system. That's what Windows would be installed on, DOS computers, things of that nature. You can have an MS-DOS area. You can have an NTFS file system, right? Y'all know what NTFS is. MS-DOS is basically just a DOS-based Windows. Would never use that. And then you have XFS, which is your X file system. And basically, it's specific to the IRIX type file system based out of Silicon Valley. Mounting. If I mount something, what am I doing? I'm making it available. I'm adding it into the system. Mount point is the point in which this device is attached. In other words, if I'm in my device directory and I have my HDA, I've mounted my hard drive A to the system, and that's its mount point. The directory structure prior to mounting anything, you're going to have your mount, you'll have a root, you'll have a data, you'll have an etc, and you'll have a home. If I mount this floppy disk, it's going to come underneath mount, right? Because I'm mounting it. All you have to do is say mount space and what you're mounting. FD0, FD1, HD1, or HDA, HDB.
You have to be in the mount directory, right?
That's where it mounts it, yes. The device itself shows up in the dev directory, but to mount it, it'll actually show in the mounted. So you can see it. If I've added a hard drive in, it'll be attached in the device directory always. But if I unmount it, it removes it out of mount. So if you're finding you can't read a specific part of your hard drive or a hard drive, go under mount and see if it's mounted, and then remount it. I've lost hard drives a couple times by doing that, where it just for some reason a system will unmount it. If there's a corruption or something and it reads it, it can unmount that hard drive, and then you're like, okay, where did this go? And then it took me some time, just trick of the trade. You want to mount it back in, and then you bring it back up. Yes?
Does Linux do plug and play anything, or if you plug it in, you're going to mount it no matter what?
No, you're going to have to mount it.
Okay.
It's old-fashioned that way.
Just curious.
Now, they may have made some enhancements to make it more plug-and-play and hot swappable. I know on servers, Red Hat does that. It has that feature for hot swappable, just like the Windows does. So I don't know if they've really put it all into the code for desktop machines, but there's not a real good chance that you're going to be hot swapping a drive out in a local machine. So I don't think that's why they don't do that. Because if you're going to put it on a server, you really want to put it on a server. MKFS, y'all remember that command? Means all it does is to format a disk on a file system, or you're making a file system. MKFS -T NTFS. Now you're talking, right? What did I just do?
You made a Windows system.
I made a Windows partition, right? An NTFS partition. And then when you unmount something, just make sure that no one's connected to it. You'll really make people mad if you unmount them, whatever device they are attached to. And this is more if you're in a bigger, if you're the only one on that Linux box, then obviously you know what you need and what you don't. Commands to create file systems. Here you go. MKFS. If you want to make a DOS, it's going to be an MKDOS-FS. If you want to do any other type, it's going to be MKFS.ext2, ext3, ext4. If you want to make an ISO, it's going to be MKISO-FS, right? And if I want to make an NTFS, I can do the MKFS.NTFS. I like just saying it's MKFS dot whatever you want to install, just to make it easier. Okay?
What is
Go
what is ISO? I mean, when I hear ISO, I think of an image file. Or, yeah.
CD-ROM.
It's just an image. That's all it is.
That's what I thought it was.
Yep. F user command with the -U option, list users in a directory. And under your etc. directory, the F stab file, you can change it and say mount this drive, make sure all these drives are mounted when you turn it on. So if you take it out of there, it won't. That's always a fun thing to do. And when you unmount something, it's U-mount, but you can either give it the device name or you can give it the mount point. Either or. It's, in other words, /MNT/HDA. Or I could just say unmount HDA.
Crashes.
Yeah,
Yeah.
pretty much.
Cool.
And then, your points or your mount points are going to be actually your dev, not your mounts. If you're going to unmount them. If you're going to do CD-ROMs, CD-RWs, DVDs, DVD-RWs, they're going to be like this. But that's to create a symbolic link so that it's easier to remember instead of CD0, CD1, CD2. Just create a symbolic link to it and change the name. As long as it points to the same thing. Your CDs, they typically use the ISO 9660 file system. And they're going to be read-only. Usually your drives are. Or your CDs or DVDs. You cannot eject a DVD or CD from a Linux box until it has been unmounted. That is the one thing that bothers more people than anything else. Your CD and DVDs will automatically be mounted to a directory underneath the media/media directory. And if there's a label for that CD, then it'll give it a CD name. And we'll give you an icon on your desktop for you to be able to connect into it just like a folder. However, you got to make sure that before you eject it, you unmount it. Otherwise, you're not going to be able to inject it. And so here's exactly what you'll see. You'll see a little CD icon, tells you what the name of it is. You can go in there and see the folders. All right. Your ISO 9660 can let you create ISO images. Remember, that's the format. Y'all are familiar with CDFS, which is your CD file system? It's ISO 9660. Okay. Just to give you the understanding of it. You can make it as a loopback to create the ISO image. Because really all you're doing is saving a digital copy of what you already have. to make an image of it. Make IOSFS is used to create an ISO image from a directory. That was your question mark. You wanted to know exactly what ISO is. It's just an image.
Well, I know what ISO is, but I don't know if it was.
No, that's what I'm saying as far as Linux goes.
Okay.
You just have to give it a file name and a directory you're going to use to create the ISO image of. So if you copy everything off of a CD, create an ISO image of that, and now you have an ISO image of that CD. There's 3 types of hard disk. We already talked about those, the PATA, SATA, and SCSIs. I'm not going to go into it again. SATA and SCSI hard disk are well suited for Linux servers because they're faster, obviously, because of the throughput. Your SCSI is going to be SDAs. Same with your serials. So it can be or your SATAs, so it can be very confusing if you have SCSI and SATA at the same time. One SCSI drive, one SATA drive. Partitions. Linux requires at least 2. Chris, this goes back to your question. You have to have a root and a swap at a minimum. Obviously, you want to have more than just those 2, so that in case file corruption affects one, that you still be able to do stuff. How many of y'all familiar with a hard drive type where you have your cylinders, your heads, your tracks, your sectors, your blocks? All of you taken an A+ course, the micro hardware course? You have not, William? Okay. A track is basically that goes around just like a CD. Okay. A sector is a slice of that pie. Okay. A block is a combination of those sectors. The cylinder is multiple platters. They're all on the same hard drive. That's really all it is. I'll put it this way. A block is multiple sectors. A cylinder is multiple tracks. Just make it a little easier to understand, because a track is what the whole plate is. A cylinder would be multiple plates. Just an easy way to remember it. And the first readable sector on the root or the main hard drive is going to be your master boot record. And here's essentially what we're talking about. A sector would be these 2. A track is the whole thing in the center, and a block would be multiple sectors. Like I said, if it's a PATA, it'll be H's. If it's a SATA, it starts with an S. Make it a little easier to understand it. Here's your root partition and your swap partition. You'll always have some on there, but right here in the very center, the first thing it reads is the master boot record. All right. So here, let's just have a little fun. If I'm on a Windows machine, I create a 4 gigabyte, which WinXP might work, on hard drive A1. What does that mean? That's the first primary partition on hard drive A. What is HDA2?
Second.
All the rest of it. That's the second partition. Then we call this an extended partition, and all the rest of it's logical based. Y'all catch that? And your master boot record's in here with grub on it. F-disk. How many of y'all familiar with F-disk? Y'all remember F-disk? It's a fun thing. Helps you create your partitions. Helps you reformat your computer. And is wonderful on a floppy drive. The CF disk is just the graphical version of F-disk. Okay. If you want to mount new ones, like we talked about, you can do the fstab folder. You do your make swaps, swap on, swap off. All swap on does is it activates that swap partition. Swap off eliminates the swap partition. Make swap, you can create another partition. Logical volume manager. What does it do?
Logically manages the
There's something I can throw at you, Chris. All it really does is just creates the volumes and manages it. It's pretty simple. Just make sure that you have enough space for the rest of your logical volumes. And here's what you get with the LVM. All it does is directory 1, directory 2, directory 3. If all these are logical, we can create it as a physical, you have physical volumes. You have a hard drive A, hard drive, that's a SCSI or SATA, SCSI or SATA, SCSI or SATA. You can put them all together and see them as just multiple, instead of multiple drives, you can see them as multiple folders. Put them all together, whichever way you want to do.
Is there an advantage to that at all?
Well, I can make a folder look like it's 300 gig when I have 3 separate 100 gig drives. So, just whichever way you want to do it. Or you can have them each separate drives. Do you want to have 3 separate names, drives on a? Let's say you have 26 drives that you have to have between your logical drives, your physical drives, and your map network drives, or 25, and you're adding your 26th, which would be Z, and you have 3 drives. What do you want to do? You want to put them all together to make them look like one drive, so you only have that one map, and that's what it allows you to do. It's more of a management type thing than it is a functionality per se. And I tell you what, we're going to stop right there for a break, and then we'll come back. All right, we're going to talk about the PV create. All that does is allows you to create. Let's go back here to the physical volume. Physical volume display, PV display, gives you the details of it, and you can create a crap. What is VG off the? I'm trying to remember now. It's been a year since I taught this, so bear with me for a second. Oh, volume group. You can create your volume group and then have your physical groups or physical drives underneath it, or your physical volumes. Y'all understand that concept? Pretty simple. You create the group first, and then you put your physical volumes inside the group. That's what VG create is. Your physical extent is your block size. If you should set it when you create it. Say, I'm going to set this block or amount of data to be in my volume group, so I can put my physical volumes in there. VG display, just like P display or PV display, all it does is display the information of the visual group. Then you have your logical, and then all that does is create logical volumes inside that. You have your physical volumes and your logical volumes inside the group. That's all it does. Does that make sense? Same thing with create and display. You're just looking at LV instead of VG or PV. I don't know why they didn't just say GV, group volume, which would make everything a lot easier. So it'd be PV or G.
Would it be kind of equivalent to disk management?
Exactly. That's all the LVM does is it allows you to manage your logical volumes. And as I was explaining, you can put multiple volumes together to see as one. You can separate them, take one and separate that to multiple ones. There's a lot of things you can do.
When you group them like that with several hard drives to make it look like one volume, can you determine which physical volume itself has the information, or say if one drive goes down? And how do
You'd
you-
have to go and look underneath the specific card or device.
Okay.
So this doesn't work unless you create the group first.
Correct.
The volumes underneath.
Correct. Because then you're looking at that group folder, and then you have your physical or logical volumes underneath it. And you can do your scans, basically. It's the same thing as displays. It's just going to scan it and tell you what's in it. I can extend, use the extend command to extend my volume group to make it bigger, to add more PVs or more LVs if I want to, or if I want to extend my LV. Remember, you can extend a logical, but you can't extend a physical. Why? Because it's a physical device. You can't make an 800 gig hard drive any bigger than 800 gig. That's why there's no PV extend. Okay? Most removable storage drives emulate your SCSI protocol. Why? Because it has a device ID. Again, most removable storage devices emulate the SCSI protocol in the firmware of that device. And it's because they have a ID. All right. Like I said, you want to check your mounted drives periodically to make sure that they're still mounted, because you can have system errors that'll kick them off. Make sure your inodes are not going out. You don't have too many inodes out there. Your disk space, make sure that you're not overextending yourself. And the more you check it, the less errors you could have.
Can you explain what an inode is again?
An inode, that's just an identifier. So if you're doing your hard link or your dynamic link, it's just like the pointer. So if I have an inode for two files, one may be on this part and one may be on here, they're linking them together. It's the pointer to the point, put the file together, is all it is. And then using more file systems typically reduces less hard disk space per file system, because it'll fill up a lot quicker, right? The smaller space, the quicker it fills up. Why do you want multiple systems? Because remember, each time you create a file system, a chunk of that has to go and be reserved into memory to allocate and to show where everything is on that partition. So the more you do, you're taking up more of your space. It may be 5 meg out of an 800 gig, and then let's say we take it down to 400 gigs. Well, I've lost 10 megs now. For each partition, I'm losing 5 extra megs, or maybe 50 megs. You're losing a percentage of it. So the more you do, the less you to start with. And then one way to go around that is to do a DF or disk free space command, and you can see what spaces are available if you need to move things over, and then shrink up or delete one of those volumes so that you can actually have more room. That extra 10 megabytes may come in handy. You never know. How many times have y'all ever tried to back up a system and run out of room on the backup? I had a situation at my church. I have a Windows 2003 server. It was a small business server, and its hard drive, no kidding, a small business server hard drive was 40 gigabytes.
Yeah.
256 meg of RAM running the server. I'm not kidding you. I kept running out of space. Well, no duh. The people in the church wanted to know why they couldn't access their stuff. I said, you have 40 gigs on here. I can get a terabyte drive down at the store for $100. Pretty darn cheap. And so now they're on a system that has I've got 6 that are in there that are 172 gigs. So they're about a terabyte on a new server, 32-bit server instead of a 16-bit server. And it's amazing how much more space they can back things up. Well, the problem is they would have, out of that 40 gigs, 10 was reserved for the operating system, 5 was reserved for, or another, no, 25 was reserved for files, and that left 10 gigs. Well, they were trying to back up those other 2 areas onto that 10 gig area and wondering why it wouldn't back up. So the df command helps you to see that and helps you associate where in my free space on what mounted file systems do I have. Oh. Then we have the directory usage. How many directories are we creating? Remember, by default, you'll come up with 2 directories. You have your root and your swap partition, right? Then you start adding all these other logical drives. You can use your desk on the directory usage to find out the size of each one of these directories. Would that come in handy? There's a stupid gnat up here and it's bothering the crap out of me. Land them. Let's see what happens. It won't be around too much longer. Then we have the dump PE2FS, which dumps all your extra inodes, tells you your inodes and free inodes.
What do you free inodes? I mean, is it just that, every time you create whatever, just obviously creates an inode? What do you mean free inodes?
It will free some up.
On free inodes. Okay.
Like if there's a symbolic link that doesn't link up to anything anymore, something like that.
It helps you see it and see where there are associations. And
It'd make more sense if it's like declarative.
file system corruption. How many of y'all have ever had a system that corrupted? Called the blue screen of death.
Oh, I got to see Windlocker not too long ago.
Windlocker?
Or, I'm sorry, Cryptlocker.
Oh.
That was a nasty virus. It looked like it was corrupting on the files.
File system corruption can really drive a network administrator up the wall and out the door and down the hallway and out to the next building. Especially if it's on your boot partition, dealing with the operating system. So you want to make sure that you have as few of those as possible. So syncing is a term we use when you're talking the writing of the data, reading it off the RAM and putting it on the hard drive. Bad blocks, those are unusable areas of your disk. And when you start getting disks that have bad blocks, just replace it. Hard drives are so darn cheap now. Just, if it's in a RAID system, pull it out, pop it in, let it go. Or move everything around, pull that hard drive out, throw it in the trash, put the new one in, move everything back over. Bad blocks are there, those that can't hold the magnetic charge, so the read-write heads doesn't do you any good. It's all zeros. How many of y'all have heard of check disk? FSCK, file system check, does the exact same thing. Checks your file system for errors. Tune2FS, basically it just looks for your file system parameters. E2FSCK checks all your external or your extra file systems, your EXTs. And then there's just some of the common areas, or what do you call those stupid things? Not attributes. Y'all know what I'm saying. The dash whatever. The options. It's right in front of me. I can't even read. You can check on the main pages for more information on those. Hard disk quotas. These are always fun as a network administrator. Have you ever set hard drive quotas on people?
Yep.
Set them on your boss and see what happens. Well, sir, if you quit looking at porn, we wouldn't have this problem.
That really happened?
Yes.
I know.
He was getting to. He had got a virus from one of the porn sites he was visiting, and it just kept downloading images. And so I saw that every day his drive kept getting bigger and bigger and bigger. So we put a quota on it. And so he couldn't do anything because it literally locked his system up. So he kept calling us and said, "Sir, if you quit looking at porn, you wouldn't have that problem." He goes, I said, "Sir, do you not want OSI involved in here?" So just,
It was on military.
yes, it was. The genre was something else, but it wasn't kids, so I wasn't as worried about it. Evidently, he had downloaded this virus, and he claims not to have visited any of these sites, but this virus keeps replicating it. And the virus that he downloaded happened to have that attribute,
It was on his profile.
but there are certain viruses that will go out and search those type of websites and pull down pictures and stuff. But this particular virus that was one of the things it did. So whether he was telling the truth or not, that's why he was able to get away with what happened. But remember, what's the difference between a soft limit and a hard limit? The soft quota just allows you to flash a warning to them saying, hey, you're going to exceed your limit here at such and such time. And they can still keep going until they reach that hard limit. The hard limit cuts you off. You can't do anything more. Again, in my ATC directory, my what's the name of that file again? fstab. You can turn on quotas on or off, and then you can set them. You can edit user quotas. You can report user quotas, or you can just do a quota command and set them that way if you want to. I like setting them in on the login so that when they log in, it automatically will check and add it on there, and they can't do anything about it. Not getting into this again because we just talked about this. RAID configuration. Y'all are familiar with RAID, the redundant array of independent disks. What is the minimum requirement for a RAID system? How many hard drives? 2. A mirror. RAID 0. Look yourself in that big mirror, right? Oh, that's right. RAID. And I was about to correct myself too. RAID 1 is mirroring. RAID 0 is the striping. RAID 5 is just is basically for RAID 5. How many drives do you have to have? 3. What about RAID 10?
8.
4. It's striping with parity. Mirrored. It's mirrored striping with parity. It's really RAID 1.0. But I call it RAID 10. Most people do because everyone knows what we're talking about. Where you're striping it amongst those 2 drives, and you mirror this set over here, so you have 4 drives. And there are a total of 7 RAID configurations. 0 to 5 give you 6, and then RAID 1.0. All right. And 0 is your spanning. 2 hard drives seen as 1. Striping is also part of that. Disk 1 is mirroring. RAID 2 we don't ever use anymore. RAID 3 and 4 are the predecessor to 5. They exist, but you don't ever see them. Why? Because RAID 5 is fault tolerant, unlike 3 and 4. And then disk striping with parity, essentially RAID 6. But it's RAID 1.0. Here's what RAID 5 looks like. 22, 1.2. Are in the same area. And then 65, 68 is the parity bit, 3. 1.3 is the parity bit, 9 and 4 are written. Y'all see how it works? You had 22 and 1.2, 22 and 12, that equals 34. 65 and 3 equals 68. That's your parity bit. All right. ISO basically is your International Standards Organization that and they created the ISO image. That's where it came from. The ISO, what did I say it was? The 1669. I'm trying to remember the number now off the top of my head.
Probably 9600.
9660 something. 9668, 9660, whatever. 9660. It is back in the. Y'all can go back and take a look at it because I never call it that. It's just an ISO image. It's a large file that takes an exact copy of your CD or DVD. That's all it is. The CD installation for Fedora 13 in this instance is 6 CDs, 1 DVD.
Took forever.
Yeah, it does. You can do it on USB now, obviously. More and more are going to the USB install drives, especially Backtrack 5, and then you have Kali Linux are both bootable from your flash. You can go to the Live USB Creator. It allows you to create these operating systems for a flash drive. Hard disk installation. You can use the Linux directly from the ISO images to the hard disk if you wanted to, or you can use a DVD-ROM just like we talked about earlier. And we're basically back to the non-standard type of installation. You can go in and say, I want to do it from these different types of areas. I'm going to set my directories to hold my images. It was Fedora ISO.
Is the process pretty much the same?
Once you get past these configurations.
No,
Okay.
I'm not even talking about that. I'm just talking about when you're so if you want to use an image to restore the operating system to a brand new disk, is the process very similar to Windows? Do you have some kind of a recovery CD or anything like that?
Yeah, you can recover it from a DVD or.
I mean, I'm just talking about recovery CD, but then just pulling the image off another device, like Windows does.
Oh, like a PXE boot kind of thing where you install it from a remote network?
Wherever I
Yeah,
target. That's very
Same thing. Because right here where the directory is holding the image, you can put on there whatever
Okay, I just want to
locality it is. Network-based installs, you still have to have an installation startup DVD or CD to get it started. Then you can do with the NFS or FTP or HTTP to pull all the files down. You just can't start the install from a remote because it'll install it on that system. Does that make sense? So you can start the install locally. So you got to boot into the bootloader or into the install boot. And then you can come in here and changing your NFS, give it the directory and things like that. That's what you were asking. And same thing, if I want to do it from the web, I can just do it from the URL setup. If I want to automatically do it, I can do it from a kickstart, the CFG file. Pre-select everything, and then just run the file. Just like the unattended install on Windows, where you have the unattended.txt. Same thing. It's just ks.cfg. You can use the Kickstart configurator tool to do all those information right here, and it just creates that config file, and then you point to that config file, and then it does everything that you put in there. Troubleshooting the installation. Computers typically have different BIOSes, so unless like you have in here, all these machines are identical, then you can do it that way. But if you have a different BIOS on a different system, it won't work. So most corporate environments, you're going to have the same, you'll have an image because you're going to have multiple computers that you buy at the exact same time. So that's typically where you're going to see those NFS type things or web or FTP downloads. You can make sure that BIOS boot order is set for that PXE boot, the proxy boot, so that you can boot to those particular location to download it if you need to. PXE boot is also a DHCP boot, so if you're booting to a network, yes.
I don't know. I guess I'm just trying to equate this to Windows so I can better understand it.
Sure.
Windows, as you may know, in the military, has standard desktop configurations that can be used to install on a variety of systems that obviously have different BIOS and all that other stuff. Is there something similar to that?
You can create one,
Okay.
but by typical, you don't want to, yeah. Right.
Yeah,
SDC. For the graphical version, you want to make sure that everything is detected. That's one thing I run into more than anything else is the video driver. It's kind of hard to look at an install when you don't have a monitor. You don't even get to see this. So, you can, there's a lot of different things you can do. If you want to do the boot into Linux text mode to where you do everything command line, more power to you. I would rather just do it this way and go through it. Installation freezes. You want to make sure you disable all your plug and play devices. If you get a fatal signal 11, it's just a RAM issue. Reseat your RAM. It's pretty simple. Just means it's having a read-write error is all it really means. AMD K6 laptop power management conflicts, overclock CPUs will all cause issues with boots or installs. Overclocking, because it will think that that's exactly what it's supposed to do, and of course, how many people have tried to overclock a computer?
I don't know, just wanna find it.
And then, if you put it in the wrong area, you might have a problem with the 1024th cylinder that you're writing into the NVR. And if you have the problems, always check your syslogs, which would be under the root folder. And I always find this funny when they say, okay, well then go look at the install log. Well, if it didn't install, how am I going to have a log? Right? Well, it's because it creates the root folder beforehand and does a log while you're installing. So it will be there. You just have to know where it's at.
On the when you're during the installation process, you're asked to check for errors. Is it checking hardware errors or just errors with the disk?
Medium.
installed?
Just the media, the disk. It's not like the newest Windows where it checks for that. To verify hardware settings, you want to look at the processor folder and look at CPU info, memory info, or modules for different specific times if you have any particular boot up problems or any other type of installation that deals with hardware. You want to look in the processor folder. Okay? And those are some of the things that you'll see. Your interrupts, your IRC or IRQs, interrupt requests, your command line, CPU info, all the devices, and give you information if you had a hard drive fail while you were installing. That's where you can find that information. Like I said, there's a lot of different things you can find in there. System rescue is going to be a small kernel like you were asking about earlier, Mark. And basically it's just a virtual file system that allows you to fix any problems that you have with the bootloader file system partitions, configuration files, or drivers. So I mean, it's a good little utility. And then you can rescue a system back from the original Fedora screen if you needed to. And here's what it does. You come up, you click yes, rescue it. Where is it going to be? It's mounted on this folder, blah, blah, blah. Here's my shell. And then it starts running the stuff, and then you go into bash shell and do what you need to do. Is there any questions on the Linux install?
And that just basically does what Windows does, repairs, replaces, or is it what is it actually doing?
It fixes the system.